Hello, my name is Sierra Proffer, and my partner for this project was Sarah Beam, and we had math practice 2, reason abstractly and quantitatively. Our first application example involves two big concepts related to the math practice in general, which are contextualize and decontextualize. Basically, students, when they are using the concept reasoning abstractly and quantitatively, they should be able to go from a equation, for example, 70 times 5 equals 350, and they should be able to easily come up with a word problem that relates to that equation. So our example was Lisa drove 70 miles per hour for 5 hours. Therefore, she drove 350 miles together. So when students are contextualizing it, they're going to go from the equation to the word problem, and decontextualization is just the exact opposite. So they're going to go from the word problem to the equation. We have another example which is very similar, translating a word problem into equation. Our example, starting with a word problem, is there are 7 apples and 14 oranges on the table. How many pieces of fruit are on the table altogether? So when a student sees this problem, they should be able to easily set up the equation. 7 plus 14 equals 21, and get their answer that there are 21 pieces of fruit on the table. Also, when students are reasoning abstractly and quantitatively, they have to be able to go from the equation to the word problem as well. Our elementary school math example that we have for reason abstractly and quantitatively is an addition problem. So Carson has earned $100 from mowing lawns. He wants to buy new headphones for $25, new shoes for $30, and a backpack for $47. Does Carson have enough money to buy all 3 items? If not, how much does he need? So students at the elementary level should be able to read this problem and easily figure out an equation to solve it, to help them solve it. So the equation would be 25 plus 30 plus 47, and we are getting those numbers from all of the things that Carson wants to buy. So 25 plus 30 plus 47 is 102, and we have to compare that to 100 because $100 is how much money he has. All 3 items cost $102, therefore he's $2 short, so he can't get all 3 items. Our middle school example involves a 2-step equation. In science class, the students need to measure a plant's growth over time. The first week, the plant was 3.05 centimeters tall. It tripled in size the second week and then grew another 2.4 centimeters the third week. How tall was the plant after 3 weeks? So at the middle school level, they should be able to see this word problem and create a equation to help them solve it. So first you would have to take the 3.05 centimeters, which is the height from the first week, and take that times 3 because the second week it tripled in size, and that gives you 9.15 centimeters. And then you take 9.15 plus the last week's, the third week's growth of 2.4 centimeters, and then you get the answer after 3 weeks, the plant will be 11.55 centimeters tall. And then our high school example is, would you rather earn $1 million for 1 month's work, or earn $1 on the first day and double every day for a month for 30 days? So this problem really can't be done without setting up an equation. It would be very hard. So you would have to set up an equation to find the sum of the geometric sequence. So once you find the sum of the amount of money you would make from doubling your money from $1, so the second day you get $2, you earn more money than $1 million. So you would want to make $1 the first day and double as you go on. So the definition of reasoning abstractly and quantitatively can be defined as students developing an understanding of the relationship between problem scenarios and the mathematical representation, as well as how the symbols represent the strategies for the solution. So basically this means they have to understand how to set up the problem and then what each symbol means. So for example, the first math example, when he had $100, the students won't just write their answer as $100 or 100. They will know that it has to be $100. So like I said earlier, the concepts involved of the of reasoning abstractly and quantitatively are decontextualize and contextualize. Decontextualize is creating a symbolic representation to help solve the problems. So that's going to be setting up the equation, and then contextualize is translating the symbols involved, so knowing what each number represents in the word problem. Our math examples connect to the math practice reason abstractly and quantitatively. So the elementary school one uses MP2 by translating a word problem into an equation. And the middle school example also utilizes MP2 by translating a word problem into an equation. And also the students at this time could use a number line to help them reason abstractly and quantitatively. It would just be another manipulative to help them solve the problem. And then the high school example utilizes MP2, reason abstractly and quantitatively, by using an equation and thinking abstractly. And here are all of our references. You can stop.